Hello my friend, welcome to my channel. So today I am going to solve a problem related to hypothesis testing. Here the difference between two means using the z-test. So we are going to use the z-test here. Let's look at the example. A survey found that the average hotel room rate in New Orleans is $88.42 and the average room rate in Phoenix is $80.61. Assume that the data were obtained from two samples of 50 hotels each and that standard deviation of the populations are $5.62 and $4.883 respectively. At alpha equals 0.05, can it be concluded that there is a significant difference in the rates? So, as you can see, here we are looking at the difference between two means of the two populations. So, let's write down the null hypothesis and the alternative hypothesis. I'm going to use mu1, the mean of the first population, and mu2 is the mean of the second population. So the null hypothesis is equality, and the alternative here, we are looking at the difference between two means, so it is not equal. So as you can see, this is two-tailed test. Now let's look at all the information here. Here we have two populations, hotel room rates in New Orleans and hotel room rates in Phoenix. As you can see, X1 bar, the first population for New Orleans, the mean is of that sample is 88.42. And X2 bar is the second population, it is the hotel room rates from Phoenix, which is 80.61. Now, here we are selecting 50 hotels each, right, as a sample. So, sample size 1 is 50 and sample size 2 is also 50. 50 hotels each, right? And then we have the information about the population standard deviations. The first population standard deviation, which is sigma 1, equals 5.62, and second population standard deviation is 4.83. Now, alpha is 0.05. So these are the information we have here. Before we do the testing, we should confirm the assumptions, right? There are two assumptions. One is the samples must be independent of each other. That means there is no relationship between the subjects in each sample, as we are considering two samples from different areas. So these two samples are independent. So the first assumption is satisfied in this case. And the second assumption is the either sample size should be greater than 30 or the population should follow normal distribution. As you can see, the sample size is 50. So it's greater than 30. So the second assumption is also satisfied. So we can use the z-test. Let's find the test statistic, which is z0. We are looking at z-scores. So since we are looking at the difference between two means, this is the formula x1 bar minus x2 bar minus hypothesized values of mu1 minus mu2. So we are looking at the difference. Divided by the standard deviation is sigma 1 square over n1 plus sigma 2 square over n2. So this is the formula. So let's substitute all the values. X1 bar is 88.42 minus 86.1 is X2 bar And as you can see here, mu1 minus mu2. So here we are looking at mu1 equals mu2. So that means mu1 minus mu2 equals 0. Divided by square root of sigma 1 square is 5.62 square. Divided by n1 is 50 plus 4.83 square divided by 50. So if you solve this equation, you will see the number is 7.45. So this is the test statistic for this problem. Here I'm going to use critical value method and p-value method to make the decision. So let's look at the critical value method. Since this is a two-tailed test, alpha equals 0.05, we divide by 2, 0.025. We need to find two critical values then, right? One is negative critical value, the other one is the positive critical value. So this region represents 0.025 and this is also 0.025. To find the critical value, you can consider the z-table and you can look at this area inside the table 0.0250 and then locate the z-score. It is negative 1.9. Second decimal place is 6. So our two critical values in this case, one is negative 0.96. So you know this distribution is symmetric. So if this is positive and this number 1.96 is here positive. So this area is your critical region. And this area also critical region. So those are the critical values. So let's find out the p-value in this case. As you can see, we have the test statistic is a very large positive number. That means if you look at this distribution, it's like 7.45 is in the tail, right? Like this. So if you look at the z-score in the table, you won't be able to find 7.45, right? Because I think the maximum in the z-table z-score is around 4, right? So here 7.45, it is very large. So if you look at this value, all the z-score less than z naught, which is probability z less than 7.45. You can see that value, this area, according to the table, you won't be able to find 7.45 like this, right? This is not available in the normal z table. So you will see that the last number you can see in the table is 0.999 something, right? It's very close to 1. So I'm going to use here approximately this value is this number. So this area is this one, 0.99 something, right? And then you can find the tail. This tail is very small. This area under the curve in the right tail is very small then, right? Because 1 minus probability z less than 7.45 gives you 1 minus 0.999 something, right? So this value is 0.00001, right? It's very small number. So that is your p-value here. So this tail. But here we have two tail tests. So you have to multiply this number by 2 to get the p-value. So p-value equals 2 times, it is like this, 1 minus probability z less than 7.45, which is 2 times 0.00001, which is 0.00002. So approximately your p-value is like this. So let's make the decision. Look at the z naught. The test statistic value is 745. As you can see, your 745 falls somewhere around here, right? So it's in the critical region. So Z naught falls in the critical region. So therefore, we reject the null H naught, right? And according to p-value, as you can see, p-value is a very small number. And you compare that one with alpha, which is 0.05. You can see that alpha is larger than p-value. So p-value is small. So we reject the null H naught. So we rejected this one, right? And then that is, you can write down the conclusion. There is enough evidence to conclude, let's write like this. There is enough evidence to support the claim. The claim is under null hypothesis. So this is your claim. This is your claim. See, right? There is enough evidence to support the claim. Claim is claim that the means are not equal. So therefore, hence, there is a significant difference in the hotel room rates, right? So that's the conclusion of this problem. So this is how you do this kind of problems. I hope you understand this question. If you have any questions or concerns, please comment. And thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.